All right, hello geometry students, and welcome to lesson 124, where we're going to look at how can I move it. Again, we're still looking at different types of transformations. The difference is we are going from reflections, and now we're going to start to look at rotations. Is the different idea of what we're going to be taking a look at today. So as we go down to this first problem, we're going to talk about rotations on a grid first of all, because that's usually the easiest way to make these happen. So notice, consider what you know about rotation, a motion that turns a shape about a point. And again, one of the key things, we always have to do a rotation about a point or around a point. Reflections you do over a line, rotations you do about a point, okay, around a point. Does it make any difference if that rotation is clockwise versus counterclockwise? Okay. We're going to look into that. If it does, when does it matter? Are there any circumstances where it doesn't matter? And are there any situations when a rotated image would lie exactly on the original shape? Okay, and so we're going to take a look at all of those different things. I'm going to have you use your patty paper, your tracing paper, to do these problems. Okay, and so what I want you to do in part A here is you're going to take your patty paper, you're going to put it over the top of this shape, trace the shape on the patty paper, and then make sure you put the point of rotation there as well, which happens to be the corner of the shape. Okay, then at that point, remember, you are going to go in and right here you're going to kind of put a plus sign so that you can see whether you've rotated it 90 degrees, 180 degrees, whatever that happens to be. So you're going to put a plus sign at your point of rotation, and then you're going to hold your pencil on that point of rotation and rotate your patty paper, in this case 180 degrees in a clockwise direction, and see where it ends up. Okay, in part B then, if you notice, you should already have the shape. You're just going the opposite direction. You're going counterclockwise instead of clockwise. Okay. One thing I'll tell you is make sure you don't just put the shape right in the middle of the patty paper, because I'm going to want you to use this patty paper for other shapes in this lesson as well. For example, in C, D, E, and F, you're going to be tracing that shape, and then same idea with G and H. You're going to be tracing those shapes as well. So make sure you kind of use your patty paper wisely. Try to put maybe each one of these in a corner or something. Okay, that way you've got your 4 different shapes. So we'll talk about that. So go ahead, and what I want you to do is I want you to give it a shot. Okay, put your patty paper over, put the plus sign, do the rotation, hold your pencil on the point of rotation, and then rotate your patty paper the number of degrees that it tells you to do it. I want you to pause the video and give it a shot right now. And then I'm going to come back and I'm going to show you exactly how it should look, okay, and what it happens and what we're going to discover, okay? All right, welcome back, everybody. Hopefully you've given this a shot. Now it's your turn to kind of check and see if you could, if you did it correctly and if everything worked out for you. So I'm going to actually go to a different program here so I can show you. So for part A, I am coming, here is your shape right here in part A, and what they asked you to do was to take that shape and rotate it 180 degrees about this corner point right here that on my screen is A. So I'm going to go down here and I'm going to click on rotate around a point, okay? So I am taking that shape and I'm going to rotate it about that point, and we are going to go, in the first problem it said to go 180 degrees clockwise is what we were looking at. So here's your opportunity to see if you did your rotation correctly. If you rotate it clockwise, here's where it should end up. There's what you should end up with, okay? So you are going in this direction. If you notice, point A and A prime are in the same spot, because that's the point where you should have been holding your patty paper down with your pencil. So that point doesn't move, because that's our point of rotation. Notice G that's up here rotated 180 degrees and is now down here to G prime. F rotated down here to F prime, and so on. So this whole shape rotated 180 degrees in a clockwise direction. Okay, and notice they did label all their points as with the primes like we talked about in a previous lesson. So hopefully that went okay. Then what I want you to take a look at is the next part. They ask you to go 180 degrees counterclockwise. And so the question is, what happens if we go in the opposite direction but the same degree? Okay, So once again, let's go ahead and let's click on rotate about a point. Oops, let me get rid of that. So I'm going to click that. I'm going to rotate it about that point, but now we're going to go 180 degrees counterclockwise. And let's see what happens. Let's see if it makes some sense. So if we take that, and notice, now there's some ones that are added here. What that is telling us is when we went 180 degrees in this direction, it actually ended up in the exact same spot as when we went 180 degrees clockwise. So one of the questions we had at the beginning of the lesson was, is there a chance or is there a time when 180 degree rotation, or when there's a rotation that ends up on itself? And the answer is when it's 180 degrees, okay? If you go 180 degree rotation, it doesn't really matter which direction you go in because you will end up in the exact same spot no matter what, okay? So there's your first two parts. There's A and B. Now, what we're going to take a look at is we're going to take a look at part C now with these kind of flag-looking shapes. And so we're going to take this first flag and we're going to rotate it 90 degrees clockwise. Then in part D, we're going to rotate it 90 degrees counterclockwise and see what we have from there, okay? So let me go to my next one. I had to kind of trace this one, so it's not quite as nice as the last one, but we have the idea. There's our flag-looking shape. Here's our point of rotation. So once again, I'm going to rotate about a point. I'm going to select my shape. I'm going to select my point. And in this case, we are going to go 90 degrees clockwise is what we're looking at. And once again, hopefully you can check. And there is what that should have looked like when you went through and you did it. Okay. So the top up here that was at 4, notice that rotated 90 degrees down here to the x-axis, still at 4 though. Okay. Notice this bottom part of the flag that was at 2, rotated to 2. And notice I did not hold, and hopefully you didn't put your pencil at the bottom of the flag. You always, when you're doing the patty paper, hold your pen or pencil at the point of rotation. So this point rotated around up to here, okay? So it's rotating around that point is what we're doing. So there's your 90 degree rotation clockwise. If now we're going to go in part D and we're going to go 90 degrees counterclockwise, if I, again, we're going to rotate about a point. I'll select that. There's that. And now we'll go 90 degrees counterclockwise. And notice there's the other direction. Same exact idea, just the other direction. Okay? So we went this way now. Okay? We went this way. So again, up at 4, and now down to -4. When it was at 2, now it rotated to -2, and so on and so forth. So that's to give you an idea. What I want you to do on the rest of these problems, these 4 problems that you have here, I want you to try those on your own, and if we will discuss those in class and see what you came up with. Keep in mind, here you're doing a 270 degree rotation, clockwise rotation. 270 degrees, keep in mind, is just 3 90 degree rotations. So you'd rotate it once 90 degrees, then you rotate it again 90 degrees, and then you rotate it a third time 90 degrees. Okay? And 360 is just 4 90 degree rotations. So that's always what we're going to think about. When we do a rotation, it's going to be some multiple of 90 degrees. Okay? And we'll take a look at that point. Okay? So hopefully that helps you out. Like I said, give those 4 a shot on your own. We'll discuss those in class just to see how you did. Okay? So bring those with you to class. Be ready to discuss that stuff. Then if I go back to the actual lesson here that we were talking about, I'm going to move on now to the next problem. So if we take a look at this next problem, it says, so what exactly is a rotation? If a figure is rotated, how could you describe it? So part A, on graph paper, it tells you to graph this line segment AB. They gave you the coordinates for A and B, and then they want you to rotate it 90 degrees counterclockwise about point O. They call it O because this is the origin. And then you'll have a segment of A prime, B prime. So if we come down here, and we notice there's my segment AB. I am going to rotate that about the origin. Notice I put the origin in red. Okay, I'm going to rotate that 90 degrees counterclockwise. Okay, so we're going in this direction. Okay, so we are going from here, from quadrant 1, we're going to rotate it over here generally into quadrant 2. So again, what I want you to do, pause the video, trace the line segment and see if you can do the 90-degree counterclockwise rotation correctly. Okay, pause the video, give it a shot. We'll be back in just a second. All right, welcome back. Here we go. Let's see how you did. So if we have point A over here, I'm going to rotate that over here. And so so that point would come to right here. That's where A prime would be located. B would be over here. That would be B prime. And now we can go through and draw that line segment in. So hopefully that's what you came up with as you go through and you took that line segment and you rotated it around 90 degrees counterclockwise. That's what you should have ended up with for part A. Part B then, it says to compare the lengths and the lengths of and angles formed by the line segments that connect points A, B, A prime, and B prime to your origin, the point of rotation. So here's what they're getting at. Let me show you this. This one I'm not going to have you try on your own because it's a little bit confusing. If I pick point B, for example, I'm going to take point B and I'm going to connect that to the origin. Then I'm going to also connect that to B prime. And what they're trying to get you to see here is, if I draw that in that green portion there, what they want you to notice is point B, the distance right here from the origin is going to be the same distance that B prime is away. Okay, so the distance stays the same. The length of the line segment stays the same. That does not change. Okay, it didn't change length. And then the other part is they want you to also notice that right there, there's your 90-degree rotation right there. They took that distance, and then you rotated it your 90 degrees, and that's where B prime. They wanted you to be able to see the actual rotation. Okay, so that's what they're talking about, kind of in parts B, C, and D here, is they're referring to these points of rotation. So I'm not going to worry too much about going through the rest of it, because that's the idea of what they were trying to get at, is they wanted you to see that when you do a rotation, there's two things, and that is, number one, the length does not change, the shape does not change at all, okay? And the rotation, they wanted you to be able to see that 90 degrees as you work your way around the origin or around your point of rotation, okay? So that is what that problem is about. If we take a look at the next one then, so that now we're moving on to the kind of the last transformation that we're going to talk about. We've talked about reflections. We just talked about a couple of examples about rotations. Now we're going to go into this last one talking about translations. Okay, so first question, if you notice here, so what is a translation? It is the formal name for a slide. That's what we're taking a look at. A translation is just a slide, is all it is. And one thing, if you notice in parentheses here, remember that the words translation and transformation are different, okay? Transformations are reflections, rotations, and translations, okay? So a transformation is any one of those, anything that you would do to a shape. A translation is a slide, okay? It is a type of transformation. So if you notice, they've got triangle A prime, B prime, C prime at the right is the result of translating the original triangle. So notice, again, we've got labels are important. This was my original. They translated this triangle. They slid it over here, and that's my new triangle, okay? So notice in part A, it says to describe the translation, okay? You're trying to describe what's going on. That is, how many units to the right and how many units down does the translation move? Now, one thing I just want you to be aware of on this one is, had they not told you which one was your starting one and which one was the image, you still should have been able to figure that out just based on the fact that it's prime. So if this was on a test question, for example, at the end of the chapter, be careful to look which one's your original shape, which one's your image, okay, based on the primes. So if we take a look, how many units to the right, how many units down did it move? What I'm going to do is I'm going to take a look at point C right here and figure out what we did to get to C prime. So if you notice, for point C, we went over 1, 2, 3, 4, 5, 6, 7 units to the right, okay? So I'm going to put that down. 7 units right. And then the other part is it also moved down 1, 2, 3 units down. So that's kind of describing the translation. It's not a rule per se like we've talked about previously where we're talking about the coordinates, but it is the translation. It's just a description of what's going on. If you notice, I'm going to come back up in a different color. If we go from B to B prime, B is 1, 2, 3, 4, 5, 6, 7 units to the right, and 1, 2, 3 units down as well. If you checked A to A prime, you would get the same thing. And what I want you to notice is that when you translate something, all points are translated, the same way. Okay? So, if you take a look at part B, then it says on graph paper, plot triangle EFG with these coordinates, and then find the coordinates of E prime, F prime, G prime, if you translate it the same way as what we just did. 7 units to the right, 3 down. Okay? So I want you to try part B. Okay? Then in part C, they ask you for a translated triangle in part B, draw a line segment connecting each vertex to its translated image. And they want you to see, what do you notice about those line segments? What does it tell you about how a translation moves each point? Okay? And if they tell you can use tracing paper to help out. I don't know that you'll really need it for a translation, but if you want to use tracing paper or patty paper, you can do it. Okay, that's up to you. All right, last problem then. Last thing that we're going to take a look at here is we're going to use transformations with reflections to learn about some other familiar shapes. Okay, so notice it says here, consider reflecting a line segment across a line that passes through one of the endpoints. So if you take a look at this picture, I'm going to kind of just sketch this in is what I'm going to do. But if we take a look and I were to take B is going to stay the same spot because it's on your line of reflection. A would go through and would reflect to somewhere over here. I'm going to say that approximately right there. And I'm going to call that A prime. So here, this line segment then got reflected to that line segment. Okay? And now, if we connect this up, and we actually draw this in now as a triangle, one of the things that they're trying to get you to recognize is, I know that this has to be at least an isosceles triangle, because that length has to be the same as that length. And I know that because it's the exact same line segment that's been reflected. Okay? One of the other things they want you to come up with as well is that in an isosceles triangle, we're going to talk about this more in a future section, there is a line of reflection right down the middle. So anything that's on the left-hand side of this isosceles triangle matches up with anything that's on the right-hand side. Okay? So there is a line of reflection that cuts an isosceles triangle right down the middle. Okay? So just a heads up on that, on one way we can use reflections to start taking a look at some stuff. Some other ideas, by the way, just a quick side note, if you're looking at reflections and we're trying to figure out how you use things in real life, let's say you go to the doctor and there's something wrong with one of your kidneys. What are the first thing they're going to look at? They're going to go through and do an MRI or something to take a look and see what the other kidney looks like. They're going to compare your two kidneys and see if they look the same, because theoretically they should. Okay, so that's one way of looking at reflection in human beings, okay, and how it can actually be applied and how it's used in the real world as you work your way through it, okay? So there is that part of it. They do right down here talk about an isosceles triangle. That is something you're going to need to know about. You don't have to do the learning log, but you want to make sure that you know that an isosceles triangle is when two sides of a triangle have the same length, okay? That is called an isosceles triangle. So make sure you highlight that something so that you have that taken care of, okay? Other than that, the only thing left then is our math notes box. And what this basically does, you can look through it. I'm not going to explain it too much, but it is a summary now of, here's a summary of reflections and what that looks like. Here's a summary of rotations and kind of what that looks like. And here's a summary of translations. Biggest thing I'll tell you, reflections, you take a shape and you reflect it over a line with the same distance, making sure that the distance is the same on each point to that line of reflection. So reflections are flipped over a line. Rotations are rotated around a point. And remember, you need a point of rotation, and you need a degree on and which direction we're going to go. Okay, so you need an angle of rotation and you need a direction of rotation. And finally, a translation is probably the easiest one. That is just a slide where you're taking something and sliding it from one spot to the other. They give you an idea down here of how you can take this line segment and we could either slide it down, we could slide it over, and you're trying to visualize that as we go to other two-dimensional shapes, three-dimensional shapes, things like that. So we're going to use this as we all year long as we go through and we look at different shapes. Okay. Practice to learn. The worksheet is attached. The worksheet's there for you. Give that a chance. Give that a look and see what you can do. And what I want you to do then is take any questions that you might have from this lesson, bring those with you to class. Any questions that you might have from the homework, bring that to class with you, and we will go over that and make sure everything is making sense the next time I see you in class. Okay? Good luck, everybody. I hope it goes well.